So with square roots or cube roots, we always want to try to simplify as far as we possibly can. So, um, right now this isn't fully simplified and this isn't fully simplified. And the reason is because there's a perfect square root we can factor out of 75. You want to look at your numbers and see if you can divide them by 9 or see if you can divide them by 25 or by 4 or by 16. These are all perfect square roots because the square roots are non-decimal numbers, right? So 75, you can divide a 25 out of it. I'll write it over here. That's a 3, and then that's still x to the 6. Look, you can break it up as a square root of this and a square root of this if you want. They're the same thing. Because if you multiply two things inside a square root, then you could put them back inside one big square root together, have them being multiplied. So this is the same thing as this right now. And then here, same thing. This one I think we can divide, what can we take out of this? Definitely a 4. I think we could take 16 out of this. I don't need a square root symbol though. Because 48 divided by 16, it's 3. We got x to the 6 still left over. Okay, so we factored this down and we broke it up into a whole bunch of individual square roots. Look, a square root is a 1/2 power. So you have x to the 6 being raised to the 1/2 power. Powers on top of powers multiply. So this is x to the 3rd. And then square root of 25 is 5. Square root of 16 is 4. And then square root of x to the 6 again is x to the 3rd, like we said. Look, now these are like terms. You have 5 square roots of 3 x to the 3rd. You got 4 square roots of 3 x to the 3rd. So this is a square root of 3 x to the 3rd. This is a square root of 3 x to the 3rd. So you have 5 of them plus 4 of them. That means you got 9 of them. So here is our fully simplified answer.